Assalamu alaikum dear students. Today in the online class we discuss the mixtures and types of mixtures. So the mixtures, they are impure substances which are made up of two or more substances that are not chemically combined. Actually in the previous lecture we discussed the compounds and there is a big difference between the compound and mixtures. Actually the compounds, they are pure substances, whereas the mixtures, they are impure substances. The compounds, they are formed by the chemical combination of two or more different types of elements which are chemically combined in a fixed ratio by mass. Whereas the mixtures, they are formed by the physical combination of different substances in any ratio. There is a restriction of the elements within the compound. However, there is no restriction for the ratio of the different substances within the mixtures. So the compounds, they are pure in nature, whereas the mixtures, they are impure in nature. Similarly, the compounds, they are formed by the chemical combination of elements, whereas the mixtures, they are formed by the physical combination of different substances. In the compounds, there is a fixed ratio. However, in the case of mixture, there is no fixed ratio of substances. In the next lecture, inshallah, we will discuss some more differences between the compounds and mixture. Now I am going to focus the main points of the lecture. The mixtures, they are formed by the combination of two or more elements, or mixtures, they may consist of different compounds, or sometimes the mixtures may consist of elements and compounds. In this lecture, we discussed that we have two types of mixtures. The first type of mixture is known as homogeneous mixture, and the second type of mixture is known as heterogeneous mixture. The word homo means same and the word hetero means different. Now we will discuss the homogeneous mixture in detail first. So the homogeneous mixtures, they are the mixtures which have uniform composition throughout its mass. Means that the homogeneous mixtures, they are the mixtures in which the particles, in which the components are equally distributed. In this picture, you can observe that the two components, that is the green and the purple components, they are equally distributed with one another. Such types of mixtures in which there is uniform composition, or the particles, they are equally distributed in all directions. That type of mixtures, they have uniform compositions. So the mixtures which have uniform compositions, they are known as homogeneous mixtures. And in the examples, we discussed the salt solution and sugar solution. After that, we perform some activities by dissolving salt and sugar in water. Inside the water, we mix salt, and in that mixture, you will notice that there is no salt particles which are visible to you people. So the salt particle equally distributed themselves with the water molecules. In that situation, you will notice that there is a uniform composition. So the mixtures which have uniform compositions, they are known as homogeneous mixtures. There is no salt particle. So the salt get dissolved easily in water. They distribute themselves with the water. So this is a very good example of homogeneous mixture. Similarly, in the second example, we mix the ink with water. And in that situation, you can observe, you will notice that the ink particle mixes well with the water molecules. And in this situation, Again, you will notice that there is an equal distribution of two components with one another. There will be no ink particles which are settled down at the bottom of the container. So, in that situation, again, there is a uniform composition. There is equal distribution of components of the mixture. In that situation, when there is a uniform composition of the components, then the mixtures, they are known as homogeneous mixture. Another name for homogeneous mixtures are also solution. So you can say that it's an ink solution and this is a salt solution. So these are two examples for the homogeneous solution for today's lecture. Now after that we are going to discuss the second type of mixture, and the second type of mixture is known as heterogeneous mixture. Now I will define heterogeneous mixture, that the mixture which does not have uniform composition throughout its mass. Means that this picture indicates you that there is no equal distribution of the components with one another. The purple color at one side of the picture indicate you that there is no equal distribution of the particles with one another. So at one side you will notice that the purple particles, they are at a higher concentration on one side than on the other side. So there is no equal distribution of these two components with one another as compared to the uniform composition. This is uniform composition and this is not uniform composition. So the heterogeneous mixtures, they have no uniform composition, and the examples which we discussed today are the sand in water. That is, when you mix sand in water, the sand particle, because of its high density, settle down at the bottom of the container. So the sand particles, they are visible to you people. You can differentiate sand from water. It indicates that there is no uniform distribution of sand with water component or water molecules. In today's lecture, we discuss a heterogeneous mixture with the help of an activity, and in that activity we mixes the mustard oil with water. In this figure, in this activity, you noticed that the yellow layer of the oil is formed over the surface of water, and that yellow layer of the oil indicate you that the oil component cannot mix with water equally or uniformly. So that situation indicate you that there is no uniform composition of the components with one another. For that reason, such types of mixtures, they are known as heterogeneous mixtures. Similarly, in the case of the heterogeneous mixture, we have another example, and in that example, we mixes the black tea in water. However, the black tea changes the color of the water, but you can notice, you will observe that the black tea particles, they settle down at the bottom of the container. They can't distribute itself equally in all direction. In that situation, you will notice that there is no uniform composition. So today we discuss that these are the two examples of the heterogeneous mixture. One is oil in water, and in the second example we mixes the black tea particle with the water. So components, they are visible to you people. And in the second situation, the black tea particles are visible to you. You can differentiate the water layer from the particles layer. So these are the two examples of heterogeneous mixture. So when the mixture which don't have the uniform compositions, they are known as heterogeneous mixtures. After that, in today's lecture, we discuss the problem, that problem is related with the heterogeneous mixture and homogeneous mixture. This is your practice problem 1.1, and in this problem we have given some mixtures, and we have to decide that which type of mixture is a homogeneous or heterogeneous mixture. In the first situation, we have sand in water. Sand in water is a heterogeneous mixture because sand cannot dissolve in the water, so the sand particle are visible to you people, so it's a heterogeneous mixture. Similarly, baking soda is like the salt, it easily dissolve in the water, so it will be homogeneous mixture. After that, we have ink in water. So when you mix ink with water, it equally distributed with the water. For that reason it will be homogeneous mixture. Similarly, in the fourth situation, we have oil in water, and oil in water is a heterogeneous mixture. So that's all for today. Thank you.